Hi, I'm Kathy Levinger. In this lesson we're going to look at the algebra of triangles, some of the algebra of triangles. Let's start with the definition of the Pythagorean theorem. If a triangle is a right triangle with legs of length A, B, and C, with legs of length A and B, and a hypotenuse of length C, then A squared, the length A squared plus the length B squared is equal to the length C squared. All of that fits with this picture. This is a right triangle in that there is a right angle at angle C. That's what this symbol indicates. The legs have length A and B, and the hypotenuse has length C. This labeling convention is used throughout the book. Capital letters are for the angles. The side opposite that angle has the same letter but in small case. Well, let's try the Pythagorean theorem and work a couple of examples. Given the right triangle below, we want to find the length of the hypotenuse. The units are in centimeters. In our right triangle, the legs have length 7 and 24, and we want to find the length of the hypotenuse labeled C. Well, the Pythagorean theorem says side A squared plus side B squared equals side C squared. Let's put 7 and 24 for side A and B, and we're going to solve for side C. 7 squared is 49. 24 squared, you could work on a calculator, is 576. We're looking for C squared for the moment. Actually, we're looking for C. We're going to add 49 plus 576, in which case we'll get 625. This is an equation you could solve using square roots. Taking the square root of each side of the equation, we would write plus or minus the square root of 625 equals the square root of C squared. However, since I'm looking for a side of a triangle, I can drop the minus version of the solution. And I know the square root of 625 is 25. The square root of C squared is C. So the length of the hypotenuse is 25, and I need to indicate units, 25 centimeters. Let's try another example. Given the triangle below, we want to find the length of the unknown side and round our answer to 2 decimal places. This time we're not looking for the hypotenuse, we're looking for one of the legs of the right triangle. The hypotenuse in the Pythagorean theorem, though, is what we use for C. Let me label the 2 legs of the triangle A and B and substitute appropriately into my Pythagorean theorem. I'll put x for A, and so write x squared. 3.5 will be substituted for B, and 7.4 for C. And now I'm going to want to use a calculator to find 3.5 squared and 7.4 squared. 3.5 squared is 12.25, and 7.4 squared is 54.76. To solve for x, I need to subtract 12.25, in which case I'll have x squared alone on the left-hand side. So 54.76 minus 12.25 is 42.51. To continue from here, I need to take the square root of each side of the equation. I should consider using plus or minus the square root of 42.51. However, since I'm looking for the side of a triangle, I'm going to use positive the square root of 42.51. The square root of x squared is x, and again with the help of a calculator, I'll find the square root of 42.51, and that's 6.5199 and so forth. To round to 2 decimal places, I'd keep 6.52 as the missing side of that triangle. There aren't any units indicated in this problem, so answering 6.52 is appropriate. Well, let's continue using the Pythagorean theorem and determine whether the following lengths of segments could form, there should be a space here, a right triangle. Well, we have 8, 4, and 4 square roots of 3 as lengths of segments. I want to substitute them into a squared plus b squared equals c squared. I need to make sure that for c I use the largest of the 3 lengths. Well, it's clear that 8 is bigger than 4, but what about 4 square roots of 3? How large is that? You can always check that before you begin a problem like this by finding 4 square roots of 3 on your calculator. That's 6.928, so not a number larger than 8, which implies that 8, if these 3 segments form a right triangle, would have to be the hypotenuse. So what I want to know is 4 squared plus 4 square roots of 3 squared equal to, question mark, 8 squared. And I'll use a calculator to help. I'll enter each side into my calculator, starting with the left. Starting with the left side, I'm going to find 4 squared plus, parentheses, 4 square roots of 3 closed twice, once for the square root and once because I'm now going to square that. I want to find that number. That's 64, and I know 8 squared is 64. I don't need a calculator to help with that. And so these 3 lengths do or could form a right triangle. Yes, the 3 lengths could be sides of a right triangle. Well, let's try that procedure again with 5, 6, and 7. 7 would have to be the hypotenuse if this were a set of sides of a right triangle. So what I want to know here is if 5 squared plus 6 squared equals, question mark, 7 squared. Well, 5 squared is 25, 6 squared is 36. I want to know if when I add those I get 49. 25 and 36 is 61, which does not equal 49. So these 3 things do not form sides of a right triangle. Well, let's continue and talk about another formula in this section called the distance formula. Here's the distance formula. Distance formula says that the distance between 2 points, one of them labeled x1, y1, and the second labeled x2, y2, is given by this formula. What you see here is d equals the difference in the x's squared plus the differences in the y's squared and the square root of that sum. Well, let's try out the distance formula. Here's what we want to do. We want to find the distance between -2, 6 and 8, 5 and give our answer both as an exact value and a decimal rounded to the nearest hundredth. Well, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We need to choose one of the ordered pairs to be x2, y2 and the other x1, y1, and it doesn't matter at all which you choose. I'm going to choose 8, 5 to be x2, y2, -2, 6 to be x1, y1. And so I'll find d equals the square root of 8 minus -5 squared, not -5, -2 squared, plus 5 minus 6 squared. Continuing, that's the square root of 8 minus -2 is 10 squared, plus 5 minus 6 is -1 squared. So d equals the square root of 100 plus 1, which is the square root of 101. Now this is the exact value of the answer, square root of 101. I'd simplify it if it were possible to simplify the square root of 101 exactly. I'm going to grab a calculator to find the square root of 101 and round it to the nearest hundredth. So on my calculator, I want the square root of 101. That number's 10.0498 to the nearest hundredth. That's 10.05. And so, as a decimal rounded to the nearest hundredth, that's what we would write as our solution. Well, let's look at an application of either the distance formula or the Pythagorean theorem, depending on how you read the problem. This problem says, how wide of a suitcase will Jeff need in order to fit his 32-inch baseball bat diagonally across the bottom of a suitcase that's 2 feet long? Well, let's draw a picture and figure out what we need to do to solve the problem. We've got a suitcase that's rectangular. Although we're not told that, we'd have to use that information. The suitcase is 2 feet long. So let's call this dimension 2 feet. We don't know how wide it is. Let's say it's x feet wide. But we want to be able to lay a 32-inch baseball bat diagonally across the bottom of it. Now, one problem that I can see right away is that 32 inches and 2 feet are not the same units. So let's change 2 feet to 24 inches and make our units match. And we'll worry about the units on our answer as we make a calculation. Well, if I want to use 32 inches, x feet, and 24 inches, notice that this dimension is also 24 inches, and I can fill information into the Pythagorean theorem, assuming that there's a right angle there. Notice that the upper half of the suitcase is a right triangle. According to our Pythagorean theorem, then, x squared plus 24 squared should be 32 squared, or we would like to know what x is for this situation to work. Well, let's grab a calculator and figure out 24 squared. That number's 576. And 32 squared is 1,024. Now I need to subtract 576 from 1,024 to get 448. And to continue solving for x, I'm going to want to take the square root of each side of the equation. And I'm only going to use the positive square root since I'm trying to find a length of a side of a suitcase. And so x is going to be, with the help of a calculator, the square root of 448, which is about 21.66.166, and so forth, rounding to maybe the first decimal place, 21.2 inches. And so the width of the suitcase would need to be 21.2 inches, which seems to be a more appropriate answer than trying to change this to feet. If you wanted to change to feet, you'd want to divide 21.2 by 12, and you could say that that's approximately 1.8 rounded feet. Well, let's try another application. A carpenter's squaring up the corner of a room in a house he's building. He measures 4.2 feet from the corner along one wall, then 6.5 feet from the same corner along the wall perpendicular. What would have to be the distance between these 2 points for the corner to be a square corner? Well, again, a picture is helpful here. It gets us started on what we need to do to solve. So let's draw the corner of a room and say that the carpenter measures 4.2 feet in one direction from the corner and 6.5 feet perpendicular to that along the corner. And the question is, what's this distance? And we assume, or we want x so that this is a square corner. So we want to make sure that x, 4.2, and 6.5 form 3 sides of a right triangle. According to our Pythagorean theorem, then, we want 4.2 squared plus 6.5 squared to be x squared. So again picking up a calculator to help, 4.2 squared plus 6.5 squared is 59.89. If I want x, I need the square root of that number, and so we'll find the square root of 59.89, which is 7.738. Let's round to 1 decimal place, and we need to call that feet to match the units in the problem. In this lesson, we've worked with the algebra of triangles. Be sure to work lots of exercises from your textbook for practice.